Log on, tune in, find out. Another good idea from Cambridge.
Good, well we've come to the fourth day now of this Faraday Summer Course, and we're very pleased to have again with us this morning Professor Tim O'Connor, who's from Indiana University in the USA. He's Professor and Chair of the Department of Philosophy there. He's also a member of its Cognitive Sciences program. And Tim has written a lot about this whole question we're tackling today, at least this morning, the question of free will and determinism and so forth. And so he's going to speak to us on free will and the scientific study of the mind, oil and water. Thank you very much, Tim.
All right, thank you. You know, we've had an awful lot of science these past few days, so let's try to get metaphysical this morning. I want to talk about the nature of free will and worries that people have about whether we in fact have free will and what the implications might be if we do not. Mainly I want to talk about worries that are actually coming directly out of sciences that directly are beginning to study human choice, decision-making, and action. But you know, people also have much more garden variety worries that simply stem from simple practical observation of their own behavior. For example, if I am free and responsible for what I do, why is it that I find myself reliably falling under the corrupting influence of the likes of David Lottie, right? And getting dragged out to the pub night after night against my better judgment. Well, this is an insoluble conundrum to me. I won't have much to offer to help you with those sorts of worries about free will. But what about worries that stem from science itself? I've got a slide here that Peter might find charming that I'm displaying it during my talk, since he would have thought it lent a lot of support to his, but just to show you that I can poke fun at myself. It's a Dilbert. It's a popular comic in the United States. Dilbert's an office worker. So I'll read to you. He's talking to his little dog down there. And the little dog says, "Do you think the chemistry of the brain controls what people do?" And Dilbert says, "Of course." "Then how can we blame people for their actions?" Dilbert says, "Well, because people have free will to do as they choose." "Are you saying that free will is not part of the brain?" "Of course it is, but it's the part of the brain that's out there, just being kind of free." "So you're saying the free will part of the brain is exempt from the natural laws of physics? Obviously. Otherwise, we couldn't blame people for anything they do." So then the question comes back, do you think the free will part of the brain is attached, or does it just float nearby? All right. I want to start by looking at things from a very grand aerial point of view. What else did you expect coming from a philosopher? But we won't stay way up here. I'm going to start off talking at a very grand aerial point of view. Then I want to get down to a little bit of nitty-gritty in terms of neuroscience, social psychology, clinical psychology, and some interesting findings that have appeared in the last couple of decades. There are two broad competing visions concerning the place of human beings in the wider cosmos. Reductionism, and Peter's talked about this. Although I'm going to differ with him in terms of how we carve up the territory a little bit. This term reductionism is often used as a term of abuse. Although there are some contemporary scientists and philosophers who embrace the name with pride. And basically, you might say, I just want to talk in very global terms about these two different competing paradigms. There are different ways of spelling out the details, of course. But the basic idea is, look, there's nothing new under the sun in a fundamental sense. You know, 13.7 billion years on in the evolution of the universe. There is, of course, a great variety of complex structures and patterns of activity that have appeared at different junctures in the unfolding long history of the universe. First complex physical structures, then chemical structures, and much later, biological and psychological structures. But, says our reductionist, all such systems are, at bottom, you might say, nothing but atoms in motion, essentially. They're wholly constituted by fundamental entities, whatever those turn out to be, obeying fundamental laws that hold in every context. And they hold just as much within the context of organized systems, including thinking, believing, acting systems such as ourselves as they do when they're located in relatively less complex systems out in nature. So sometimes people use the term nothing buttery for this. There's nothing but particles in motion. This reductionist vision has had a tenacious hold not just on the beliefs, but even on the imagination of many philosophers and scientists since the 17th century. That's where this problem begins to come up, because the prior physical paradigm, the Aristotelian paradigm, was very anti-reductionist. Okay? Some people find it difficult to conceive how it could be false. Right? So the thought is, well, look, if everything we see is composed of tiny parts of some sort, then the parts are where the action is at. Right? In the words of the great physicist at the end of the 19th century, Lord Kelvin, there's physics and there's stamp collecting. Right? Well, despite his protestation, I view Peter Clarke's position as a form of reductionism. But he's trying to dress it up, make it respectable. He's tying a bright red ribbon around the pig of reductionism. Saying it's not so bad, really. The alternative to reductionism is what I'll call emergentism. And this competing vision, in some sense, wants to say at least some complex systems exist as irreducible wholes. Right? The emergentist slogan is, the whole is somehow greater than the sum of the parts. These composed but emergent systems exercise, in some sense, some kind of top-down causality that on the microscopic behavior of its very own parts, the parts of the system, that in no way reduces to, but is in fact something over and above all the activity and interrelations of the composing parts. And I think it's clear that the emergentist vision clearly better, and even Peter concedes this, the emergentist vision better fits our ordinary pre-reflective way of understanding ourselves as knowers, and doers. So we think of conscious agents as, in some sense, a distinctive category of being. Why distinctive? Because they have capacities of thought, emotion, and intentional action that are not present in non-conscious systems. And we think these are, in some sense, fundamental or irreducible capacities. And then we think of human persons as distinctive sorts of conscious beings. We have enhanced capacities of thought, emotion, and action that simpler kinds of animals lack. These are things we ordinarily suppose. All right, but once we get beyond the competing slogans in this impressionistic way of stating reductionism versus emergentism, what do these opposing visions really come to? You might say, what's the cash value? What kind of empirical difference would it make in the way we theorize about the world to embrace one or the other of these visions? Well, I want to talk about something called the game of life, which was invented by the mathematician John Conway, I believe in the early 70s or maybe late 60s. And I find that it's a really helpful way to think about these issues. Conway's game of life goes by a fancy name, which is cellular automaton. It's a kind of abstract mathematical model that unfolds by fixed rules over a two-dimensional grid. It's kind of like a little toy world. I mean, that's the way I want to think about it. It's a flat two-dimensional world. It's got grids. It's like graph paper with a lot of small grids. And each of the cells you might think of as constituting the atoms of the world. Okay? And what's really nice about Conway's little game that he describes is it's extremely simple. And so you can very easily make apparent what would be the difference between what I'm calling reductionism and emergentism with reference to Conway's very simple world. You know, if you start talking about quantum mechanics and stuff, we're all kind of hazy, you know, because it's all very obscure, even to physicists, it's obscure how to interpret quantum mechanics. So if you think in terms of this little toy world, then you can see what the essential difference is and then say, well, there's some sort of more complicated analog of this when it comes to the real three-dimensional continuous world that we inhabit. So it unfolds by fixed rules over a two-dimensional grid. I'm going to tell you right now, everything you need to know about Conway's game of life, and you'll have it. It's very easy. Don't need to know any math. Okay? 2 basic properties for each cell. That's all there are. You're either alive or dead. That's it. Okay? Simple. You know, instead of charge, mass, spin, you know, all these sort of things, just live or dead. You can't have both. It's one or the other. And then there are just 3 rules that wholly determine the evolution of the grid from one moment to the next. Okay, it's not a continuous world, so there are next temporal moments. Nice and simple. It's very intuitive for us. It's a discrete world, right? It's not physically continuous and it's not temporally continuous. 3 rules. They're called the birth rule, the survival rule, and the death rule. The birth rule says a dead cell at time t1 that has exactly 3 live neighbors. There's 8 surrounding it. If you think about it, 3 on the bottom, 3 on the, including the diagonals. There are 8 surrounding it. And the birth rule says if you're dead at a moment, but you have 3, exactly 3, not more, not less, 3 live neighbors, then the next moment you become a live cell. Okay, that's one rule. Survival says if you're a live cell and you have 2 or 3 live neighbors, then you stay alive. And then the death rule says, in all other cases, the cell dies or remains dead. That's it. There's your physics. Okay, everyone got it? Don't worry, I'm not going to quiz you on the details, but you get the basic kind of picture. It's very, very simple. Very, very mechanical rules that apply. And you can determine, by studying the grid at any given moment, you could compute, okay, what is the total state of the grid going to look like at the next moment? In a very simple way. Here's what becomes interesting about this, that over time, stable clusters of various kinds arise, right? As these properties of live and dead are switching, at certain times, because of the fundamental rules, certain stable clusters begin to form. And they exhibit a macro level pattern of activity, a large scale pattern of activity and interaction with other cluster types. So people give names to these. You can go online and you can see there's all kinds of variations on the game of life. And depending on the initial conditions you set in your first state of the world, you can get all kinds of very different large macroscopic patterns later on. So it's very sensitive to how you set up the world initially. So you get things called oscillators, gliders, puffers, eaters, and you can probably figure out what the characteristic properties of these things are just from their names. And here's the important thing. These macroscopic properties and behaviors can be studied and predicted in ignorance of the basic rules. So if you suddenly came to a life world in mid-stage and you were seeing these large macroscopic structures along with a few scattered live cells here and there, but you ignore those, you're only interested in the macroscopic ones, you could devise rules that actually govern how these things interact without ever having been told about the birth, survival, and death rule, right? So looking at the image on the screen, you can see how different starting points give rise by the same basic rules, either to stable configurations, to repeating cycles, or an eventual blinking out or death. So up on the top, if you have 4 squares, if you were to apply, and you have nothing going on colliding into that, if you apply the 3 rules, it will tell you just to keep that, right? That state will be stable, okay? Others have stable pattern. They go through a cycle, and then the cycle continues. Well, it goes through a certain transformation, then it hits upon a stable pattern, okay? That's what you have in the second and third. Sorry, I realize this isn't super hard to see. I tried to find a good image online. And then you'll see on the 4th row, death. Okay, that last 2 square, the next step after that is blink, it goes out. There's no live cells at all, okay? And then the second to last one, you get a pattern, right? That pattern will oscillate. It will rotate through. All right, so let's think of Conway's 2-dimensional grid, as I said, as a kind of toy world. People have, by the way, since designed more complex 3-dimensional versions of Conway's world that make it closer to our world, and there are all kinds of fun things you can do with that. So then I'll say that the 3 basic rules, birth, survival, and death, constitute, and the initial state, together with the initial state, constitutes the fundamental physics of the Conway's life world. The high-level stable and cycling patterns can be thought of as its chemistry or biology, if you like, right? And then there are also interesting patterns of interactions among these and more complex structures. You can get nested levels of interesting patterns that are all explanatory, well, that are all independent of one another in the sense that you can study the rules at any one level without knowing the rules that apply at the lower levels. And that's kind of interesting. People said, you can see where this is going. You know, this is a way to think about our own world. The fact that you can do biology in ignorance of physics, or at least certain kinds of biology, right? These high-level patterns, while different in form from the low-level patterns, so here's why I say this is a kind of reductionism. They do not in any way alter the basic patterns. And in fact, it's the basic patterns alone that truly drive the world's evolution in this toy world. The state of every stable cluster at any moment is wholly fixed by the properties of each cell at a prior moment. And its evolution over time is fundamentally determined by the basic physical laws. So it's interesting that you get these high-level patterns that have predictive power that arise out of the basic physics, but there's no sense in which these high-level patterns are driving forward any part of the evolution of the world. It's all happening, I would say, in the basic level, right? Because there's a one-way determination relation from the basic level up to the high level, right? Nothing about the high level is needed to fix what's happening at the low level. So if we think of the fundamental rules in life as causal, thank you, then each macro level event, such as a glider's changing position over an interval, has a micro level cause. The sum of the micro level causes of its components' positions and their behavior, and thus a micro level causal explanation. In principle, it's there to be had. Macro level events are not doing anything extra over and above what the micro level events are doing in order to bring about the position and behavior of any of these macroscopic objects like gliders and eaters and so on. Macro level properties and events then, if all this is true, I say that a natural conclusion is that macro level properties and events do not make a difference to the behavior of objects in life, do not make a fundamental difference to behavior. So it really models a kind of reductionism. But it's a kind of reductionism that makes sense out of how can it be that biology and chemistry and biology, various branches of biology can be explanatorily and conceptually independent of the more fundamental level if the fundamental level is indeed explaining all things. How do we get different levels of explanation? Well, the life world sort of shows you how that could be, because it's very simple and transparent how that happens. Is our world an analog of a life world, albeit one that is three-dimensional, perhaps, spatio-temporally continuous, and with a richer inventory of basic properties? That's the question I want us to ask. And relatedly, are all organized phenomena in our world grounded in comprehensive underlying patterns that hold without exception in every context, fully determining the world's evolution? The reductionist says yes. Many physicists, right, just take it as a guiding assumption. Of course the answer is yes, right? I want to question that. I at least want to ask, why do people presume that when it comes to our world? Is it for conceptual reasons? Or is it for empirical reasons, or what? Or is it just a methodological presumption? Or I think there are a lot of people that strongly have the conviction that the answer to these questions is yes. But it's unclear to me what the basis for presuming that answer is. So in order to sort of think about what might settle this question, we need to begin by seeing that it need not be the case that our world operates like Conway's life world. Okay? So imagine that you are handed a tall stack of very large numbered sheets of graph paper, 1, 2, 3, 4, 5, 6, 7, right? And you're set in a room, and you're supposed to study these papers one after another and try to discern the rules governing transitions from state to state. So you got these changing snapshots of a Conway world. All the colored squares are the live cells. Okay, and so you're asked, okay, tell me what the basic transitional rules are for this world. After flipping through several pages, if you're rather bright and you're a good math student or an engineer, you're liable to hit upon the birth, survival, and death rules as the most compact way to capture all the transitions that can be observed in each cell from moment to moment. Continuing to check subsequent pages to verify that these rules hold without exception, you hit upon a page, let's say page 200, where the result departs in a small way from what the rules predict. Okay? And you observe that the divergence, it's not spread equally, it's not like there's a small departure throughout in all regions of page 200, but it's restricted to the immediate region of a complex star-shaped cluster that first appeared on the previous page. Okay? That's, you just make that observation. And then flipping ahead beyond page 200, you observe that as more of these star-shaped clusters appear, owing to the basic rules governing how clusters form, their evolution too, once they appear, departs from what the three basic rules predict. And further investigation reveals to you that the divergence is identical in form in each case. It's always a similar sort of divergence. Okay? All right, so this is what you observe. Question. Should you be surprised that this two-dimensional world you've been given to inspect behaves in this way when these clusters take shape? Would you think it objectionably strange or magical if our world turns out to be like that? Well, it seems to me that might be the proper reaction if the departures from the simple rules happened willy-nilly. They were totally unpredictable. There's no way to get a handle on it. Sometimes you get this kind of departure, sometimes that, and there's no way to capture in terms of some kinds of rules when and why the divergences occur. But in the scenario I've outlined, the new patterns, once discovered and the conditions of their appearance are learned, will become wholly predictable. You'll begin, after a period of time, you'll begin to then be able to predict without having to observe what will happen on the next page. There are sufficient conditions involving organized complexity of a certain kind. What kind? It's just a brute empirical fact what the relevant kind is. You have to learn that by experience. But there are sufficient conditions for the appearance of the new behavior. So, for example, the new birth rule has the form a dead cell with exactly 3 live neighbors becomes a live cell, except when occurring within the bounds of or immediately adjacent to a star cluster, in which case, right? You have to have these rules that invoke high-level conditions, right? That only have application, of course, in the context where there are the high-level conditions obtained. Otherwise, you could get by with just the basic rules, right? But if you want truly comprehensive rules, it has to take on this disjunctive form. And as star clusters come into contact, forming yet more complex structures, we need more modifications of the original rules. And you find, eventually, let's suppose, that the most compact way to capture the overall behavior is something like this. You have to assign primitive or emergent properties to star clusters. Call them bright or golden, right? Just, it doesn't much matter. It's kind of like charm, right? Or something like that. You just say, we've got a new basic property that's doing fundamental causal work here, so we just need to assign it a term, right? To capture that, but we functionally specify what that property is. It occurs when there are configurations of precisely this type. And we functionally characterize the precise impact of such properties on the ordinary micro-level dynamics via additional laws that are no less fundamental than the basic rules, though they have application only in limited context. It's as if they these special case rules that invoke high-level conditions are merely latent until such a time as the right kinds of structures appear. Right? So if you were the Laplacian calculator, again going to our world, observing what was happening in a pre-biological world, you would be surprised, right? Because you would think the most compact way to understand the unfolding evolution of this world is in terms of just fundamental micro-level laws. And then at a certain point, whatever that first emergent property might be, and whether there are any properties, that's an empirical question. We'll get back to that, right? Does that happen in chemistry? Does it happen in biology? Is it restricted to conscious minds? Those are empirical questions. But at some point, you're going to get if you're this computationally unlimited Laplacian calculator, you're going to find that your calculations don't match exactly what you're starting to observe, right? But all is not lost. You say, hey, what's going on under, why is this departing? And you begin to associate the departures with certain kinds of configurations, and you find that you can actually get a tractable handle on it, right? You just have to have more complex rules that irreducibly evoke macroscopic context, right? That's the anti-reductionism part. And then I say, well, so if this were true in our world, they could be accounted for naturalistically, provided we enrich our conception. So you might say, well, this would just be magical if this happened in our world. This would just be, this would be God. Perhaps the only way we can explain this would be God just, boom, he decides when these configurations happen, he's going to put a irreducible basic fundamental property directly associated with a complex object, right? And there's something objectionably anti-naturalistic about supposing that our world is like this. We're warranted in ruling out from the get-go any sort of scenario. But I want to say there's no reason to suppose that. It's an empirical issue, whether everything is fixed bottoms up by rules that hold in any and every context, or whether at certain junctures, certain structure types become crucial to explaining how the world evolves. That's an empirical question, right? And you can make sense out of it just by saying that, well, in addition to live and dead in the life world, or mass, charge, spin, and so on in our world, whose causal dispositional profiles are largely captured by the original unmodified rules. What is negative charge? Well, it's that property of fundamental particles that interacts with other similarly charged particles in this sort of way, interacts with oppositely charged particles in that sort of way, right? You functionalize what you mean by negative charge, right? But then you say there are also dispositions towards behavioral discontinuities that were there all along. It's right there in the microphysics. It's just that you wouldn't know about it until the right conditions for triggering these dispositions kick in. They're merely they're merely latent, absent the required configuration, a form of organized complexity. So then it becomes an empirical question. Are the fundamental elements of our world like that? Do they have these latent, hidden dispositions to give rise to fundamental structural properties, right, that persist only if the configuration continues to persist? That then becomes an empirical question. How would we decide whether that's true of our world or not? Well, I go back to that slide that I had previously. One reason you might have, well, first of all, it should be decided empirically, right? It shouldn't be decided by a priori presumption or the relative tidiness of a reductionist picture, right? It appeals to the physicist or the philosopher, right? We like tidy pictures. The reductionist picture of the world is a tidier world, right? The laws, the truly comprehensive laws, are tidier on a reductionist vision of things. But that's just an aesthetic consideration. That shouldn't be determinative. At the end of the day, we need to go out and look, as someone was saying, right? God is free in creating the world. We got to go out and look. What kind of world has God made? Has he planted the seeds, so to speak? Has he so imbued the fundamental elements of our worlds with the capacity to give rise to interesting emergent properties, perhaps associated with conscious agents generally, and capacities of a sort that need to be empirically investigated, or has he not? Right? How many teeth are there in the mouth of a typical horse? Well, you got to go out and look. You don't try to do some a priori deduction, right? And it should at least be noted that emergence is not just a theoretical possibility for us. It's not just an interesting possibility, right? That the nature of animal consciousness, right, and perhaps mentality more generally, appears to be, and most reductionists admit this, appears to be a spectacular counter-instance to the otherwise quite successful, quite beautifully successful reductionist program that we've seen, especially in 20th century science, in application to biology, and indeed to chemistry with quantum mechanics. Our conscious states seem to disclose qualities that are fundamentally unlike the qualities that are described in terms of fundamental physics, or indeed of biology or chemistry. And there's the particular phenomena that is the focus of our discussion today, the further seeming fact of conscious purposive choice that human beings at least make. We all suppose in practice, whether we're reductionist or not, that most adult human beings are, to a degree, self-directed agents, and as such, properly subject to moral appraisal. Now, there's a lot of debate, as Peter alluded to, about what the necessary conditions are about truly being considered free and morally responsible, and having significant moral worth, as we take persons to have, such that, for example, imposing harm or death on a human being in most circumstances is a grave moral wrong, right? This is common ground among most human persons, whether theist or non-theist, whether reductionist or anti-reductionist. But it's very hard to see, from a clear-eyed metaphysical point of view, why these things should be true. Why the taking of an innocent human life should be a grave, prima facie, a grave moral wrong, if human beings do not, in the final analysis, make any fundamental causal difference to how the world unfolds. They are simply organized, stable structures of a certain kind, whose fundamental properties and whose behavior is wholly fixed by impersonal properties and processes that govern all of matter, right? Including this lectern, that we don't think it's a grave moral wrong if I smash up this lectern. It's very hard to see. I'll just assert that. So we have motivation. Now that's just an appeal to how we conceive human beings, but it's very fundamental to our way of thinking about the world. Scientists are often supposed to say, well, that's not how you do science. You don't bring kind of common sense convictions. I mean, imagine we did physics that way. Folk physics is pretty hopeless, right? There are people you can go online and read about studies that elicit what ordinary intuitive views about physics are from just ordinary human individuals. Like, right, most people think that if you drop something out of a car window when you're speeding along a highway, that it literally goes back, right? Stuff like that. True, but this is a much more fundamental assumption. I think even the very activity of science presupposes that human beings consciously and purposefully engage in behavior that know what they're doing, and the behavior is a reliable consequences of the goals they set out in performing experiments. Right? If you didn't think that, right, then why would you take seriously the results of studies that are reported in journals, right? If you didn't think these studies were in fact designed and carried out with the specific goal in mind of testing various hypotheses, and to do so under the rigors of the particular experimental setup, and so forth. Anyway, because most of my time I don't want to be talking about this, so I realize I'm kind of waving my hands a bit, but I think there are deep problems with following the reductionist. It turns back on science itself, and at the end of the day, you might be sawing off the branch on which you sit if you're a reductionist in terms of the way you view the product and the activity of science itself. All right, well, all that concerned a high-level matter of the sort philosophers love to debate. Where do things stand on the ground when it comes to the actual sciences that are directly concerned with human thought, motivation, and behavior? Things like neuroscience, Peter's area of study, but also social and clinical psychology, which we may not have represented here. Since time is short, all I can do is quickly gesture at a whole raft of really interesting recent data that, according to some, directly challenge the idea that human beings ever exert direct control over our own choices and actions. Okay? And I'm going to take it, as indeed many of the scientists who are trying to challenge the pre-reflective view of human beings as morally responsible agents also assume, that free will does require significant causal indeterminism as a necessary condition, not a sufficient condition, for human freedom. I didn't really intend to talk about why you might think that is so, but let me just throw out, there's also a theological, in addition to, I think it's hard to square the conception of freedom with strict determinism by the past, but if you're a theist, you should have an additional reason to not be happy with compatibilism, saying determinism and freedom and responsibility are compatible. Why? Because it looks like it makes God out to be the author of sin. If God foreknowingly sets up a deterministic world system and knows that what the total consequences over time are going to be of that system, including the most heinous moral actions. You know, think of the most sadistic kinds of heinous actions that people sometimes engage in. And God has purposely brought about a world with just that sort of motivational structure and the ensuing behavior, right? If you're a compatibilist, you say human beings are responsible, but that's consistent with saying that God too is responsible. Just like I can be responsible if I'm a crazed US president of hitting a button, you know, that sets off a complicated process that eventually launches a rocket that starts a thermonuclear war. That's a very indirect consequence of my action, but if I know reliably, if I have good reason to think that will be the consequence, I'm responsible for that outcome, right? It's just so God, you know, all the more so, who would know completely and in utter detail in a deterministic world exactly what will result from setting up such a deterministic world system. So you know, and this isn't a new problem, right? The theological determinists, such as Jonathan Edwards, famously, who's a philosopher theologian, discuss this at some length, but I'll just say I think it's all a wretched subterfuge, what they try to say about this to get God off the hook. So you've got a theological motivation as well as just the motivation of freedom and responsibility just don't seem consistent on its own terms with determinism, according to certain disputable arguments. But we've got these empirical studies. So I got off the web, a snapshot from the Telegraph. This is Patrick Haggard, who's a neuroscientist, who is a key figure in a certain kind of study that I'm going to refer to a bit later on. And there's somebody applying a magnet behind his head, and you'll understand the significance of that in just a moment. Talk about the kind of study, you know, neuroscience, free will, and determinism. I'm just a machine. Patrick Haggard says we don't have free will. I'm a neuroscientist, and I know that. I have good evidence from my field of study. I could have gotten many. This is, I don't know about here, but well, this is actually taken from the Telegraph. So here, as well as in the U.S., you get lots and lots of reports, breathless reports of this sort. I'm told that in Germany a few years ago there was quite a bit of a row when some famous scientists, including, I can't recall the name, Wolfgang something or other, a famous physicist in Germany, along with many co-signatories, took out ads in major newspapers, basically announcing, we have no free will. Humans are not morally responsible, but science has shown this, right? And now we must begin the long, hard task of rethinking our legal institutions and so on. And this got a lot of public attention, and there were some other scientists who signed a competing resolution saying, no, that's all crazy. Yes, it's true. The science, you know, is studying a lot of this sort of stuff, but the claims that are made are exaggerated, and this is just not true. And big public stink about the whole matter. So that's on one side. On the other hand, then you occasionally encounter something like this. Somebody saying, well, maybe human beings don't have free will, but boy, it looks like fruit flies have free will. This is from Science Daily. Go look it up. I won't tell you about this. They're saying, you know, the astonishment, just saying, look, there seems to be genuine random spontaneity in the behavior of fruit flies when we monitor the behavior very carefully. So there's all this kind of stuff going on in the air in the popular press. Okay, so let's talk about some of the studies that actually have been done. So Delgado and others, Michael Gazzaniga, more recently has done similar studies. Delgado noticed when he was doing brain surgery on someone that he touched an area, I guess, associated with the motor cortex. And this is, as I understand it, when you're having brain surgery, at least in those days, you were kept conscious, right? You only needed a local anesthesia. You only have, the brain itself doesn't have pain sensors, right? So there's no pain associated with directly touching the brain. But of course, the skulls, you get a local anesthetic for the skull, and it's, you know, there's a lot we don't know about the brain, so it's good to keep the patient conscious so they can kind of tip you off if you're doing something you oughtn't to be doing, especially Delgado back in 1969. But he discovered, you know, he touched, I think, with a probe, an area of the motor cortex, and the person's hand shot up, like that. And Delgado said, oh, why are you raising your hand? And here's the really interesting thing. The person said, apparently quite sincerely, oh, I was trying to get your attention. And it was something that was, you know, I don't know, I can't remember what they made up right on the spot, but sincerely. They made up a story that we have good reason to think wasn't true about, that it was it was a direct stimulation of the motor cortex. It didn't go through any decision-making process. All right, so that's one sort of study. The other, back to that picture with the magnet behind Patrick Agard's brain, Brazel Nettle and associates did the original study, that it turns out if you wave a magnet behind one part of the brain and ask people to make a simple unforced choice, like raise your left hand, raise your right hand. Well, we know that the right hemisphere of the brain controls the movement of the left hand, it's contralateral, and vice versa. Turns out that if you have this, magnetic stimulation of the right hemisphere of the brain, and the person doesn't know about it, and you ask them to choose, you choose, which one, left or right, they will disproportionately raise their left hand, right, if the stimulation is over here, and similarly vice versa. Contrary to what you would expect. The actual, since most people are right-handed, there's a bias towards movement of the right hand when you ask people to do this, but it's significantly out of whack with the expectation. Okay? And what's interesting about this is you ask people, did you feel some kind of weird compulsion towards doing that, or somehow did you feel any less free? And then they'll say, no, I just chose. Right? So there was obviously a significant causal influence that they were oblivious to. That's the point. And it's a causal influence that's not a rational causal influence. You might say it's a brutally physical causal influence. Finally, and most famously, Benjamin Libet, I think the first study was in 1983, and there have been many, many studies since. Patrick Agard and Hakwon Lau and some other people are now doing much more sophisticated successor Libet-style studies. But they did a study where what they would do is they'd sit you in a room, and you have in front of you a clock with a very fast-moving dial, something that I think makes about 3 rotations per second or something like that. It goes very rapidly around, but it still has the markings of 1, 2, 3, 4, 5, 6, and through 12, right? And what they asked you to do was, we want you to make a spontaneous, free decision to wiggle your forefinger on your right hand. Do it within 30 seconds, because we're going to ask you to do this several dozens and dozens of times throughout this 2-hour experiment we paid you to participate in. But, within that interval, you decide. Don't pre-plan. Don't say, okay, I'm going to do it when the clock gets due. No, just you want it to be spontaneous. But when you do make the decision, when you feel yourself, when you feel the urge or want or desire, one problem with this is to use all this language interchangeably, or make the decision to move your finger. We want you to be paying attention all the time to that moving dial and note exactly where on the clock face the hand of the clock was when you made your decision. Okay? And people would do this, and they would run hundreds of trials. And the basic upshot was they concluded that they noticed, and while you're doing all this, you have a skull cap with a lot of electrodes all over monitoring the electrical activity over your skull. Okay? And it turns out that on average, they inferred somewhere from 200 to 400 milliseconds prior to the announced time in which the person thought they made the decision. And 200 to 400 milliseconds, I'm told in neuroscientific terms, is a significant interval of time in terms of electrical activity. There was a steady spiking of electrical activity. You might say a kind of preparatory spiking activity before they say the person was aware that they were about deciding. So there's a sense in which Libet said the brain had decided before you did. Libet was actually a dualist, a mind-body dualist. He was a neuroscientist. But the brain decided unconsciously, because it's just a brutally physical thing, it decided before you did when you were going to move your finger. Okay? Now, we don't have time to get into the details of this. You might say, well, wait a minute, there's a lag time in terms of your perception. They discounted for that. That was all carefully done. No one really objects to how they did those calculations. There's some kind of spiking activity going on. Physical activity seems to be associated with the decision to move your finger. So Libet concluded, and he was really disturbed by this result. Human beings don't have free will. But he hypothesized that, well, here's maybe what people can do is this. The brain decides what to do, but you can consciously veto that decision of the brain. Right? And in fact, he did design later experiments where he asked people to decide to do it, but then catch themselves before they actually moved it and stop it. Right? And he thought he found experimental confirmation for the ability to do this. And so some people have said that Libet doesn't believe in free will, but he believes in free won't. That's what we have. All right, that's neuroscience. Clinical psychology. There's a phenomenon known as anarchic or alien hand syndrome. You might remember Peter Sellers in Stanley Kubrick's film, Dr. Strangelove. It's a case where an agent exhibits purposive behavior, but the agent sincerely experiences it as unwilled, right? This is, but it's not random. It's not a spasmodic kind of act. It might be like reaching for a glass of water, but the person seems surprised that this is happening. Sometimes they'll try to stop their own hand from doing that, but it's clearly a purposive. So a psychologist will say, look, there's goal-directed behavior clearly going on here. It's not a random movement in your hand. It's a smooth movement towards a glass of behavior. And so it's a purpose. The only purposer in the neighborhood here is the agent. So it's a purposive behavior of the agent, but they don't know it, right? And why is this? Well, why is this significant to think about free will? Well, we think conscious, our part of our reason for believing ourselves to be free is we seem to consciously experience ourselves as freely engaging activity. And this kind of phenomena seems to show that the experience of freedom and the purposive activity can come apart in principle, right? And leads people to speculate that maybe these two distinct phenomena, the experiential phenomena and then the actual motor behavior, purposive motor behavior, come about by two very different causal pathways that just are often in sync, but in principle can come apart. And schizophrenic people with severe schizophrenia can have delusions of being controlled by outside agents that we take it are not actually controlling their behavior. Right? But they sincerely, they don't experience the behavior they engage in as something that they are doing, right? When in fact, in some sense, it is something they are doing by unconscious desires and so forth. All right, finally, the low-tech area of social psychology. Psychologists have given reason to think that we are susceptible to having false beliefs about our own agency induced by others. So, for example, if you take David, and you ask him to think dark, nasty thoughts about Jeff, say maybe even give him a voodoo doll and have him stick pins in it while he's thinking these nasty thoughts about Jeff. And then we have Jeff, who's actually a confederate, the experimenter, sort of pass in front of the agent at some point, feigning some kind of sudden condition, like, I have these severe headaches, and it's just crushing, debilitating. David's tendency to believe that he had something to do with that will go up significantly. Okay? Or if you do something as simple as, sometimes they will put somebody in a room and they tell them, now don't press this key. If you do that, this is in the early days of computers when a lot of us used to be really scared that if we hit the wrong key, everything would just get erased. And you were always very panicky using a computer in the early days, late 80s. And you tell them, don't hit this key. In fact, they didn't hit it, but at some point you cause the thing to seem to shut down. And then you have, people nearby, just are berating the person. You did it, you idiot. You just, wrecked this program and everything. The person will come to believe, yeah, I did it. Even though they didn't do it. They were being very careful not to do the alleged thing. So you can induce false beliefs in people about what they've done socially in various ways. Even more striking is people make moral choices in certain experimental conditions. It turns out you can alter their environment in ways that they themselves don't take to be relevant to their behavior. But statistically, you'll get a very different pattern of behavior when you vary these environmental factors. Example, you have some experimental confederate have a broken down car with the hood up, seeming like they're broken down, but it's in a neighborhood that should seem safe to most people and so forth, and you observe how many people stop to help this stranded motorist. These would be in the pre-cell phone days. Now we just say, oh, they got a cell phone, they can call, right? We don't think we need to help anyone anymore, right? But so it used to be common. You'd stop. Can I help you? Can I take you somewhere to help get your car fixed? And the control setup is just the ordinary. What's the pattern of people that do this, right? And you monitor lots of people passing through this neighborhood. But then you alter the environment in the experimental condition where either you put a very unpleasant noise in the background, like a jackhammer, it's just really loud and annoying, or a really unpleasant odor, very strong odor. And then you say, okay, does this influence how many people stop? And it turns out dramatically it influences. Okay? And what they'll do is the people who drove on by, didn't stop, they'll be stopped much later on. People will wave them down and they'll say, oh, excuse me, did you see, that person stranded there? Yes, I did, and everything. Why didn't you stop to help them? And they'll say, oh, well, whatever they'll say. Different people say different things. By the way, there was a really bad odor over there. Was that a factor in why you chose? Oh, no, that wasn't why I did it at all. But statistically, it had a profound impact. So we know it was influencing people profoundly. But there's reason to think they sincerely didn't think it had an influence on their behavior. All right. I see I'm going to need to speed up. Now I've got you all worried about free will, and I've only got a few minutes to try to persuade you that you should relax. What should we make of these studies and results? The first thing, I think, is we need to clarify the target. So the modest, the poor philosopher doesn't have too much to contribute to empirical issues, but one thing that we try to do is to sort of clarify concepts, right, and make certain distinctions between related concepts. And I think this is really important here. A lot of people who discuss these studies, including the studies authors themselves, seem to run together concepts and categories that I think we should all recognize are importantly different. One of these is will, or the category of will or desire, which term actually encompasses at least 3 distinct phenomena. We need to keep these separate when we think about the different types of studies. So we might, first let's consider the category of what we might call minimally voluntary action. An action that unfolds just automatically, rather than being something we consciously will, while fitting a desire or intention that we have, whether it's conscious or an unconscious intention, but it's not compulsive or manipulative. I think a lot of our action is like this. When I bike to campus each morning, right, I go the same route every single day. I'm not consciously willing to turn left here. I'm thinking about, but somehow it happens. I get there and I don't get hit by a car. It's happened many, 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 many times, right? I'm engaging in minimally voluntary action. I'm not really willing anything. I'm not attending to what I'm doing. There's some kind of subconscious motor routine that's stored, and however it gets executed, there's the environmental stimuli, and it's all being carried out, but I'm not consciously monitoring this at all most of the time. My head's in the clouds. I'm thinking about something, right? Another category is urge or want, a desire, a felt desire to perform an action. Sometimes we act on felt desires, sometimes not. It's not a choice itself. It's just a desire, something, a sense, felt inclination. Third, and I think this should be our target when we're talking about free will, is willing. We might call willing, or we might say consciously forming an intention to act. That is an intention here and now to act, an executive intention to act. It's a purposive, action-initiating event. That is either, I will do this now, or come 5 o'clock, I will do this. Come 10 o'clock, I will meet David in the pub, okay? And we do engage, at least it seems to us we engage in willing in this sense, but not, episodically. Sometimes when we're confronted with alternatives, we have to make up our mind, right? This is an episodic, it's not a continual thing. Right? As I've been talking to you, I haven't been consciously willing to do this or that. I'd get all tripped up if I did that, right? Most of my behavior, it just unfolds. All right, so that's the category of will, desire. But what about belief? Well, we have beliefs concerning our own actions. But importantly, we have beliefs before our own action about what we're about to do. Beliefs during our actions, what I am now doing. And beliefs even immediately after our action about what I just did. These can come apart, right? But that doesn't say anything about the phenomena of willing itself. The fact that you can manipulate me to even very quickly after I've done something, to think I did something that I didn't just do, doesn't tell you anything about the process of whether I initiated in a purposive, uncompelled way the action itself, right? And it just turns out that humans engage much more often than we realize in ex post facto revision about things we've immediately experienced. We can have beliefs concerning the causal consequences of our basic action. We go on the basis of environmental stimuli if there seems to be some kind of counterfactual variation of some phenomenon in the world with my action. I think I'm causing that result out there in the world. But it's an inferred belief about the effect I'm having in the wider world. Finally, the experience of agency. I want to separate this from willing itself, the subjective experience of acting. Right? So there's you might call an actish phenomenal quality. Sometimes when we consciously choose to do something, we have this sense of unwillingness right now. But that's a subjective affect. It should be thought of as distinct from the willing itself. right? It's a seeming, if you like, inner observation of what we're doing. But it's an experiential thing. And then there's a more general sense of authorship or control, being, someone who is controlling what he is doing. I have that experience even when I'm not willing what I'm doing. So when I'm riding on my bicycle, I don't think of what I'm doing as somehow being controlled by somebody else, or it's being controlled by me, but it's just I'm going on autopilot. It's in line with what I intend to do, and I'm permitting this behavior to unfold. And in some cases, people lack this sense of authorship, even though we have good reason to think they are purposely controlling the behavior. All right. Well, so I suggest, I'm really running short of time here, so I just suggest if you apply these distinctions to a number of the studies that I talked about, you will discover that in some cases, the studies are just, even while interesting, are just not to the point. If the question is whether human beings ever make free choices that ground moral responsibility. For example, the fact that you can manipulate my beliefs after the fact about whether or not I did something just a moment before doesn't tell you anything about whether in the doing of the action, right, I, in some significant autonomous way, controlled the doing of that action. That's just a separate question about the manipulability of my beliefs, the fragility of my beliefs and the accuracy of my beliefs after the fact. Automatisms, like the alien hand syndrome, right? Automatisms need to be seen in the wider context of the fact that I've already emphasized that there's a great deal of automaticity to human behavior. Much of what we do is automatic, and it's a good thing. You have to expend a lot of energy to consciously focus and decide something. If you did that all the time, you'd never get anything done, and it'd be exhausting, right? If you had to consciously deliberate about engage in an act of will 200 times a day, that would be exhausting. And as William James remarked over a century ago, in some cases, it would be positively counterproductive, right? So when you quickly walk down a flight of steps, if you start to try to carefully consider the placement of your feet, you're liable to end up crashing. It's better done automatically than to try to consciously control it, right? So this is a general phenomenon. What's different about the automatisms, like anarchic hand syndrome, is that the behavior, there's the lack of the general sense of authorship, and the behavior doesn't seem to correspond with the agent's own standing intentions. Unlike when I ride my bike, that's what I'm intending. I want to get to campus, right? So there's a mismatch, and that's what's striking about the phenomena, right? But that doesn't tell us anything about cases where we do take ourselves to be consciously willing, deciding what to do, right? And whether or not that belief we have is illusory or veridical. There's lots to say about the Benjamin Libet case. Let me just make a shout out to a book for those who are really interested. It's a short book, beautifully written by a philosopher, Al Mealy, M-E-L-E, called Effective Intentions, where he just systematically talks about a whole variety of things going on in the Libet study and suggests it should not be interpreted the way that Libet and others have interpreted it. It's just not plausible. It's a really implausible way of reading what's going on. If you stop to think about the Libet study, you've already decided when you agree to participate in the study that you are going to lift your finger, and you're going to do it within a relatively fixed interval of time, right? And then you're being asked to kind of introspect and observe within yourself this rising urge or desire or decision to move it. So you're putting yourself in a kind of passive position of an observer, a self-observer, right? Which isn't something we ordinarily do. There's reason to think when you reflect on what you're being asked to do, right? It's not at all a paradigm for what we would take truly spontaneous behavior to do. If I have to kind of watch myself and notice that first inclination towards doing it, that's a very different sort of thing. There's lots to say about the Libet stuff, but I just don't think the Libet studies, interesting as they are, at all have this very strong significance that is given to them by some thinkers. All that said, and I will finish up in just a couple minutes here, I think the empirical sciences that study human action do have a lot to tell us about free will. We need to engage in a project of kind of softening the idealization that certainly shows up in traditional philosophical thinking about freedom of will, and maybe even in ordinary human thought, right? We need to recognize that human decision-making is a messy matter. We're subject to all kinds of influences, right? Good 19th century novelists recognize that, influences that we're not always aware of, but contemporary science shows us in more profound ways kinds of influences over our behavior that we're not always aware of. And this needs to impact our understanding of what free will really can be for human beings, that it's a much more fragile thing, it's a more limited thing than a kind of idealized, godlike freedom, right? Totally aware of, they're being subject to no outside influences, right? Totally aware of one's own motivational structure, right? Not subject to any kinds of problematic, aberrant influences that one would wish not to have been there, right? Human freedom is not like that. But we shouldn't go to the opposite extreme of saying, because we're not like that, therefore there's no such thing as freedom of the will. And in fact, it's not, the key thing to recognize is it's not all or nothing. Many of the skeptics, the scientists who write, like Daniel Wegner, a Harvard psychologist, author of the book The Illusion of Conscious Will, which is a very good book, say, well look, the ordinary conception of human free will is, I did it, period, that's it. That's the sum total of the explanation of it. Well, we know from contemporary science, that's not true. There's detailed factors influencing your behavior. Therefore, it's obvious human beings don't have free will. Well, that's a ridiculous conception of free will. I did it, period. I'm the decider. I decided, right? Of course, we recognize that we're influenced to varying degrees by all kinds of factors, and we need to incorporate this into the way we think about free will. It can come in degrees. It's not all or nothing, right? We need to recognize that much of our behavior is automatic, first of all. Sometimes it seems that we have greater freedom to the extent to which we are consciously aware of the factors that are influencing our own choices. When we're not aware of those factors, it seems to diminish our freedom, because I can't reflect on and choose to be motivated otherwise or subject to rational scrutiny my motivations if I'm not even aware of what they are. So sometimes I'm less free just because I'm being powerfully influenced in unconscious ways than I recognize. And it comes in degrees, and it can vary dramatically over time, even within an individual. So, degree of awareness for each of the motivating factors behind our belief. This comes in degrees. Sometimes we're dimly aware of things influencing our behavior. Other times we're very strongly aware, sometimes totally unaware. I'll just quickly flip through this. It might be okay for my freedom if I'm not consciously aware at the time I act of a motivating factor, but it's the kind of factor that if I were to become aware of it, I would reflectively endorse it and say, oh yeah, that's a good reason for my acting, right? It's another thing when I'm being influenced by factors like ambient noise or odor that I don't take to be, shouldn't be relevant, morally relevant to whether I engage in helping behavior, and in fact it is powerfully influencing me. Seems like in that case, that kind of factor is actually diminishing my freedom, and so my responsibility, perhaps. Finally, the last thing I want to emphasize is the degree to which my motivation, my psychological structure is itself, in part, a product of my own past free choices. Okay? And indulge me here, I'm going to engage in a thought experiment concerning angels. Okay? It's inspired by Robert Grosseteste, a medieval philosopher who this is the typical medieval kind of thought experiment. He imagines an angel that literally exists only for an instant. But in that instant, the angel is willing to do something or not to do something. There was no antecedent, right? Could such an angel be free? Could that be a free will? Could God create an instantaneous angel? It only exists for an instant. All right. You might doubt the coherence of that, so stretch it out by a few seconds. Imagine an angel who just pops into existence fully formed and is poised to make a decision. Right? The angel takes herself to have a past, but she's deluded about that. She's got all these false beliefs about her past, right? She's like, oh, okay, here I got to decide this or this, and here are these factors, and she decides between the option, makes a choice. 5 seconds later, okay? Call that angel Angela. Is she a free agent, right? Well, you might say, yeah. I mean, she made a choice. She wasn't determined, let's suppose, in the choice she made. She did it on the basis of some motivating factor that tilted one way rather than the other, and she made her choice. And now imagine a counterpart of Angela, Angelo. And Angelo is intrinsically, in terms of his intrinsic state during that 5-second interval, identical to Angela. The only difference is he actually has a past. The fact that he is the way he is as he enters this deliberation is, in part, a causal product of a long sequence of previous choices that he made. His beliefs are not about the past, they're not delusory, right? And let's suppose Angelo makes the same, happens to make, but non-deterministically, as it happens, makes the identical choice to Angela. Is one or the other of these angels more free than the other? I would say Angelo is more free than Angela. Why? Because his choice has been powerfully shaped by factors that he himself had a hand in making through past choices. I think freedom grows through time, insofar as there's an integrity of we engage to a very limited degree, to be sure, in a kind of self-forming project as adult persons, right? And this is important to our conception of freedom, right? I mean, imagine that there were a wireless technology of the 21st century, so that a neuroscientist could manipulate your motivational structure, the strength of your desires and beliefs continuously. But you make choices. They don't choose your favorite. All they do is, dramatically alter the strength of the motivating factors. But you make choices in just the way that ordinary human beings do. We'd say there's less freedom there, right? Because you don't have the capacity over time to sustain a whole course of behavior. Engage in long-term projects that you can reliably carry out in the future, right? So history is relevant to freedom. All right, so summary. The empirical sciences of brain and behavior, I think, potentially have a lot to teach us about the extent and scope of human freedom once we recognize the mistake of thinking that it is all or nothing. Either you got it or you don't, period. 0 and 1, binary properties. Human freedom is, in fact, always limited, fragile, and variable over time and across ages. It is the sort of thing that comes in degrees, a fact that should inform not only our philosophical scientific theorizing, but also our moral understanding and assessment of one another. Okay, thanks.
Thank you very much, Tim. I'm sure we're going to have a great discussion. And who's going to kick it off with some questions? A question. We're all stunned. Yes, philosopher first.
So a question about emergentism, Tim. So the idea is that if you're an emergentist, you think that somehow there are levels of reality, and the higher levels sort of are based on the lower level, but there are new kinds of properties that show up, and that, as you have been suggesting, that might exert a downward causal influence on the lower levels. Now my question here is emergence, as you were thinking of it, is that a concept that explains how it is that higher levels come about and do the sort of things that they are capable of doing? Or is it simply, is it a concept that you're using to describe a not very well understood phenomenon? So is it an explanatory concept, or is it a descriptive concept as you're using it?
Right. Sometimes we can give...
Just summarize the question.
Yeah, so the question is, well, is it really an explanatory concept? If there really were these high-level features that suddenly appeared in the right kinds of organized structures and exert a downward causal influence, is invoking that way of thinking about things, is that really explanatory, or is it maybe just putting a label on it, describing a behavior, a form of behavior that is in fact unexplainable? Why would you think it's unexplainable? Well, because there's no deep underlying structural, you can't account for the high-level behavior as the total resultant of all the interlocking, more fundamental causal factors and the way they interlock with one another, right? And it's true that often explanation takes that form, right? Being an emergentist is not to say that reductionistic explanations are not very often powerful and true, right? Very often, high-level behavior is, we have good reason to think, I take it, merely the resultant of a whole lot of interlocking lower-level behavior. And where that is the case, in principle, it allows a kind of deeper explanation in terms of something more fundamental. But at some point, things have to bottom out, right? And, suppose, just for the sake of discussion, that electrons are fundamental entities, right? Then the characteristic behavior of an electron, can we explain it? Well, we describe it in terms of how negatively charged particles co-evolve with other kinds of properties of fundamental particles, right, in terms of equations, right? How exactly what the cache value, what the contribution of an instance of negative charge is to the overall state and momentum of a system or something, right? Is that, is it explanatory? Well, I would say, yeah. I mean, if you say it's explanatory in this sense, you're saying this is a fundamental entity. It has no structure, right? Negative charge is not a structured property. By hypothesis, we'll just assume that, substitute whatever the actual fundamental property is. It's a fundamental property, and it has certain characteristic behavior associated with it. It's not a reductive explanation. It's a descriptive explanation, but it's not saying it's inexplicable. I mean, the behavior, that's the kind of thing negative charge is. So similarly, the emergentist says, so if you have some property of a star-shaped cluster, call it golden, right? That's a fundamental property. Golden interacts with structures in this characteristic kind of way. And there's a further thing to be said about golden. Golden never appears associated with unstructured particles. It only is associated with structures of the right type. And it's a causal product of latent dispositions of the fundamental properties of the things that compose golden systems. Okay? So what I want to say is all explanation bottoms out in principle, and so it's on a par with what you would say about fundamental physics. It's an equally basic kind of force or causal property.
Yeah, David.
Is it even theoretically possible that one could discover something about the fundamental particles if emergentism is true? That could lead you to realize that emergentism was true, or that those, actually, not that emergentism was true, but that star-shaped cluster would have an irreducible effect. Is there anything at that fundamental level that would ever give you...
Well, in principle, I think as a practical matter, it's extremely unlikely, especially since the most plausible candidates for there actually being emergent properties are associated with conscious or willing systems. That is, just to say that there might be emergent properties is not to say that every well-defined science you're supposing that these are emergent features, right? The 19th century British emergentists did think that way, right? People like John Stuart Mill, various other thinkers, they thought, well, you got physics, and then all of a sudden chemistry is a whole new set of patterns. It's an emergent, relatively insulated, autonomous realm of activity, and then you get biology, life, is this fundamental, irreducible quality that separates living from non-living systems. We know all that to be false, right? There's deep interpenetration, right? We can explain a lot of features at various levels. So that's the first thing to say. It's not supposing that it's always an empirical question where and how frequent any kind of emergence appears. But in principle, if you're a Laplacian calculator, if you're not subject to computational limitations, if you can monitor, inside the light cone surrounding an individual human being composed of billions upon billions of neurons and much larger numbers of fundamental particles, and you can track each and every one of those variables, right? And you can apply the laws of physics, what you take to be the fundamental laws of physics, directly to this enormously complex system, right? And do the calculations and notice within a certain region, perhaps of the brain of these systems, a certain kind of characteristic aberration from what you would have predicted based on the laws that you saw applying in simpler systems, then yes, you could. So it's in principle. But in practice, I think it would to ever have that kind of direct confirmation, I think there's good reason to think it will forever be impossible. Now, so then that leads to the question of, okay, well, would there be a less direct, less utterly conclusive kind of verification that could be based on sort of trying to do it in a stepwise manner? You say, well, if we have good reason to think chemical atoms are, in all cases, no matter how large, not just hydrogen, but all the way out on scale, their behavior, their properties and characteristic behavior are wholly determined quantum mechanically. And if we can, then go up to biochemistry, and if we can kind of, through various approximations, get good reason to think that reductionism isn't being violated at any level, Could we maybe more realistically have evidence? Maybe, so what you would want to do is, as scientists get to a better and better understanding of precisely the regions of the brain associated with conscious experiences of one kind, or willing activity in the frontal cortex, right? Sort of executive command, portions of the brain that are involved in executive command. If you could say, look, we can really trace this large number, these large-scale structures, neuronal structures, in terms of purely neurophysiological patterns of activity, and they're the kinds of patterns of activity that are not fundamentally different from the kinds that go on in parts of the brain where we don't think there's anything funky going on. Then maybe, it would be that kind of thing. But to be really, to be really rigorous, it would have to be, to compare fundamental physics to, and apply it, and that's a pipe dream.
Please.
To what extent do you or do you not think that human thinking, even mathematical thinking, is computational? And what do you think of, what's your opinion on John Searle's Chinese room argument? And if, depending on the nature of human thought, be it entirely computational or non-computational, how do you think that influences free will?
Good. I don't know if that influences free will, but I
Did anyone hear the question?
Okay, right. So you're raising a question about, sometimes people say there's a problem for reductionism when it comes to conscious experience. I alluded to that, Peter alluded to that this morning. But, like David Chalmers, that's it. Everything else is easy problem. Understanding the intentional, that is the goal-directed, or the fact that some states are about other states outside of themselves. We have beliefs about the world outside of ourselves. It's a peculiar property of mental states, right? Unlike the physical state of this lectern, it's not about anything, it's not directed at anything, but the intentional states of my brain are directed outward. And you might wonder, okay, so our intentional properties, this capacity to have content, to be directed at the way the world is, or like desires also have content. I want the world to be a certain way. Are those properties reducible or irreducible? Or are they, ultimately can they be understood, you said computationally, a kind of reductionist analysis? Could it be given? I'm skeptical. I think intentionality raises problems as fundamental as conscious, experiential, subjective qualities. And in fact, one reason, among others, for thinking that is I don't think we can neatly divide conscious, experiential states from intentional properties of belief and desire. I think conscious believings have certain subjective, qualitative aspects. There's something it's like to have a certain kind of desire, right? But it also has a content, and so these properties interpenetrate each other. So if the purely subjective, qualitative character of the conscious state poses a problem for the reductionist, well then similarly for the intentional state, because I think it's a mistake that reflection should show. You can't really tease these kinds of properties apart. But all right, so John Searle gives a Chinese language argument. You're in a room and you're given a manual, and you're just handed these arbitrary symbols, right? And you consult your manual, and then you give output symbols. That's all. You don't know. Now, in fact, what you're doing is instantiating Chinese communication. Right? You don't know. The symbols are Chinese characters, and you're following rules, very complicated rules for putting together decoding, matching it up with what you see in your book. But you have no understanding of Chinese, right? Okay. And so then the thought is, well, if understanding of a language, for example, is purely computational, this system should be instantiating, right, the understanding of Chinese, because you set it up to be just a large-scale physical duplicate of what a computationalist takes to be going on in your brain when you're understanding language. But plainly, the agent in the room is not understanding Chinese, therefore there's something wrong about computationalism. That's, in essence, what Searle's argument is. People have responded in different ways. They'll say, well, it's not the person in the room that understands language, it's the whole system. It's the room plus person is understanding Chinese. But, I'm skeptical about those sorts of replies. But that's all I'll say about that. You can Google Chinese room and see the way philosophers have responded to that.
Hand to the back, please. Yes. Yeah, that's going. Yes.
Tell me something about the concept of strange attractor, and whether that attractor could be thought of as mental categories. Because I don't really understand a lot about that. You haven't mentioned it, so I don't know if there's anything to that or not.
I don't either. I mean, I know I've heard a little bit about this, right? But yeah, within life worlds and these other kinds of things, you the term strange attractor. Is there anyone here who feels like they're knowledgeable about this, so that if I don't fumble about saying things that, Ian.
A strange attractor is a technical description of a certain type of dynamical system in which generally speaking, chaos takes place. I think it's very unlikely that it's easy to apply this to the problem of free will. That would be my
Peter, did you want to add anything to that?
I was going to say the same thing.
Okay. Right. Completely unified front line of people here. Yes, next question. Yes.
I've got a question about your angel example. The philosopher Richard Rorty said once that our free will, sort of our experience when we make a decision, it's based upon our previous experiences. So from that, to what point do you think our environment dictates our free will? And if it does, could our free will be considered deterministic in a reverse sense, where what we do going forward is based upon what we know and what we've done in the past, rather than something that could be already determined in the future?
If I understood you right, you're expressing a kind of deterministic view of the world, the sum total of all the influences that impinge upon me right now will yield a unique outcome. That's what determinism says, that given a total input state, you have a unique possible outcome. Right? That in essence is what determinism is applied to the world moment to moment. There's always a unique outcome consistent with the laws governing the evolution. And given the total state of the world, an indeterminist says, no, what you've got is a space of possibilities. Not just anything can happen. It might be, but there would be a limited range of possibilities, possibly weighted by different probabilities. Right. And I just want to say I don't find compelling the view that our world, we should suppose our world to be deterministic. It's plainly not total unbridled freedom. I don't even know that would be freedom, right? That every time I make a choice, I have no propensity towards one thing or another. I could never form long-term plans about what to do if tomorrow, if I decide I'm going to go to the university and get this degree because I want to pursue this career, and if I think that's going to have no even probabilistic influence on the likelihood that I wake up tomorrow and have that same intention, why bother, right? We care about our long-term projects. So plainly, we are powerfully influenced, right? There are certain things that I wouldn't even consider doing right now, right? I'm physically capable of stripping off all my clothes right now and running out of this room. I think there's zero chance of my doing that. It's just not in the realm of possibility. Someone else, a psychologically rather different sort of individual, it might be a live possibility. They might even have a sense of compulsion to do that and have to resist. It's a real possibility. So our freedom is clearly constrained, and it becomes really morally significant. There are a lot of hard cases, of course, when we think about this. We think of individuals who are raised, either who we think even biochemically are disturbed in various kinds of ways, or just environmentally raised in such profoundly, and as David would say, these interact, right? But who are raised in such profoundly impoverished and brutal circumstances that they don't have normal human sympathy, right? And one could imagine, but is it that their free willer, their basic capacity to make choices, is absent? No, we don't think that they're fundamentally, structurally different in terms of capacities, but what they're capable of contemplating is profoundly different. And if they're not really capable of, in a sustained way, of making morally virtuous kinds of choices, we might say they're not, even though they're not impaired in terms of fundamental capacities to make choices, they don't bear the level or perhaps at all moral responsibility for how they act, right? So then it becomes, so exactly what the space of possibility is for an individual becomes really important. I think in practice, we make rough and ready conjectures that most human beings raised in relatively normal circumstances have the capacity to make, profoundly moral, immoral, to make the right choice, although it might be much easier than others. But this is something that could only be known to God, what the possibility space looks moment to moment, looking forward is for any individual. And that's why I say that it should influence our moral theorizing when we really take into account the degree to which we are profoundly shaped by various sorts of influences, it should temper our assessments of moral culpability of individuals, right? Psychologists have, what's the term they use, the prime, I'm sorry, I'm forgetting the term, but they say there's a fundamental tendency of human beings. We see for ourselves all the excusing conditions, the complicating, factors and stuff. But when we assess other people's behaviors, we tend to be rather cut and dried, right? They just made the wrong. Sorry.
Fundamental attribution error.
There we go. Thank you. The fundamental attribution error, right? We need to be careful about that. We can be much harsher in our assessment of other individuals than we are of ourselves when we see the complicating factors.
Okay, well, I actually think we're going to wrap up just in a second. I think Tim's given us a wonderful overview this morning, so let's thank Tim very much.